Hello everyone, welcome back to the another session in design and analysis of algorithms. This video will discuss about applications of dynamic programming, and one of the application is all pairs shortest path problem. This is also called as Floyd Warshall problem. This topic you will find in third unit as topic number 8. So this video will be going to cover three things. The one is what is all pairs shortest path problem, how to solve this problem, and the complexity of the problem. The third is implementation part of the problem, because this is one of the experiment as far as lab syllabus is considered. Now, so what is all pair shortest path problem? To understand this problem, now consider a graph. The graph G is equal to V comma E, and it is a directed graph. So take one graph for the better understanding. 1, 2, 3, 4. So this is a graph. As I specified in the first point, it is representing you that it is a directed graph. So we already come across with the graphs in the first unit. In the directed graph, U comma V is never be is equal to V comma U as far as directed graph is considered. So the direction which it represents U comma V is not equivalent to V comma U. Now, so the second point is, let cost be a cost adjacency matrix for G such that cost I comma I is equal to 0. So let us represent cost adjacency matrix for this. Cost adjacency matrix I am representing with A. Now the matrix is self loops are 0. That means cost II comma 0. That is 1 will be 0. And 2 will be 0, 3 will be 0, 4 will be 0. And the next point, the cost I comma j is the length of the edge I comma j if ij is belongs to E of g, edge of g graph. And cost of ij is infinite. There are two chances that cost of ij can be a value, cost of ij can be a infinite. When cost of ij will give you a value, the direction if it goes from 1 to 2, then it will have some value. Now let's consider some weight of the graph, cost of the edge, that is some 3, 4, 1, 2, 5. So randomly I have taken some figures for the better understanding. Now 1 comma 2 cost is what? 1 comma 2 cost is 3, right? Now look at the direction and copy the value over here. Now 1 comma 3 is what? 1 comma 3 also we have edge. Now 1 comma 3 is 2. 1 comma 4 also we have edge which is 1. Now it is okay. 2 to 1. Now look at 2. From 2 there is no edge which is coming out of it, right? So there is no edge. So 2 to 1 distance is infinite. And 2 to 3 there is no edge. So it is infinite. 2 to 4 there is no edge, it is infinite. Maybe to reach this 3, 2 vertex need some intermediary vertex to travel. Either it can take intermediary vertex 1 or it can take intermediary vertex 4. But there is no direct edge from 2 to 3. Right? Now from 3. From 3 also there is no edge from 3 to 1, infinite. From 3 to 2, infinite. From 3 to 4, no edge. Now, from 4 there is an edge to 2, that is with the cost of 4. But 4 to 1, there is no edge, infinite. 4 to 3, there is an edge with 5. Now, so here, point is very clear that we may not have direct edge from one vertex to other vertex. But it is true that you can reach this 4 via any vertex. So now this is what the cost adjacency matrix for this example. So this problem is what? To find shortest path between every pair of vertices. That is what all pairs. So all pairs the shortest path, the name itself it tells that we'll be going to find out shortest path between every pair of vertices. That means every pair of vertices, in the sense, let us suppose what are the paths which are 2 from 1 to 2, 1 to 3, 1 to 4. If you take second vertex, the same. What are the paths which are available? Shortest path from 2 to 1, 2 to 3, 2 to 4. If you consider the starting vertex is 3, then also you have to see the same. If you consider 4, then also you have to check which is the shortest path among 3 to 1, 3 to 2 and 3 to 4. So 4 to 1, 4 to 2, 4 to 3. So these are what the things what you have to do it in all pair shortest path problem. Now this looks similar to single source shortest path problem, that is Dijkstra's algorithms. So we were discussed Dijkstra's algorithm also. So it is as simple as it is, because in Dijkstra's algorithm, and this algorithm also we were called with the name of single source shortest path, and the same is called as Bellman-Ford algorithm. So all are representing one algorithm. These are what different names for the same algorithm. Now in this algorithm, we'll find out shortest path from only one source. So for finding the single source shortest path, the time complexity we were seen in the last example of single source video, that is of big O n square time. Big O n square time is required to calculate the distance or else the shortest path from one vertex, from one single vertex. Now if I wanted to calculate it is from all the vertices assume that it is n, then that would be big O of n square into n. So it is big O of n cube. So big O of n cube is the time complexity for this all pair shortest path problem. Now let us see how we can apply dynamic program on these problems, because dynamic programming is what it works with an optimality principle. So in the last video we were discussed about dynamic programming. Dynamic programming will works with optimum principle or principle of optimality. What it suggests us, it says that every problem can get solved by taking sequence of decisions. What decisions will take when you are at vertex 1? When you wanted to see the path which is existed from 1 to t, 1 to 3, 1 to 4, it is like one stage. From vertex 1, this is one stage. In this stage, what is the shortest path? And again we'll go for the second stage. In the second stage or in the second decision, from what is the shortest path from second vertex and third vertex and fourth vertex. These are what sequence of decisions to get the optimum solution using dynamic programming. So finally, using dynamic programming, in each stage we'll take a decision. So that is what the mean of dynamic programming, how it will be implemented in all pairs shortest path. So we'll take some example. Before we'll be going for example, there are some points what we will refer. The all pair shortest path problem is to determine a matrix A such that ai comma j is the length of the shortest path from I to j. So we'll take a cost adjacency matrix as we were representing in the previous slide. The matrix A can be obtained by solving n single source problems using the algorithm shortest path. Right. Now we'll take some example. So this is our example. This example I have taken from the textbook, prescribed textbook from OU, that is Fundamentals of Computer Algorithms, written by Horowitz, Sahani, Rajashekaran. This is what prescribed textbook for us. I have taken this example from that textbook. As soon as you see this graph to solve all pairs shortest path problem, immediately you have to take cost adjacency matrix, and this is the matrix what we were seeing in the previous slide. So how I got this matrix? I am representing this matrix with A0 or A0. So what is this A0? The cost of the given graph. The cost of the given graph. That means how many vertices you have in the graph, you just take all the vertices. So 1, 2, 3, 4 I have taken, right? Now 1, 2, 3, 4. So as far as the all page shortest path principles or features are considered, all self loops are 0. That means cost of I comma I is 0. So cost of I comma 0, cost of I comma j will be a value if it is having some edge. I comma j will be an infinite if there is no edge. Correct? Now So these are the values what I have taken from the graph. So 1 2 1 0, 2 2 0, 3 2 0, 4 2 4 0. So 1 2 2 there is a path. This direction you can see 1 2 2 there is a path. So the cost of this path I have noted here. 1 2 2 the cost is 3. So 1 2 3 I don't have any path. Correct? It is from 3 to 1. There is no path from 1 to 3. So as I do not see any path from this, then 1 to 3 is infinite. Okay, now this is what A naught. Now what is our problem, or what is our the way of finding the solution for this problem is finding the shortest path from each vertex. So now I am going to find out from first vertex. So I am representing with A1. So when you wanted to take from A1, whichever values you are having here in this matrix, that values may not be the shorter values, or the if you take these values, let us see, here it is an infinite. Infinite means what? There is no path. To travel from 4 to 2, there is no path in this example, correct? But you can have a path when you travel from 4 to 1 and 1 to 2. So using an intermediary vertex you can reach to 2, correct? So that is the reason we'll delete all the values, we'll ignore all the values here. You can see A1 matrix. That is the reason we were taken only the first row, first column, right? Now the middle values we will be going to get by applying the formula of all pair shortest path. Now we'll see that formula also, how to calculate how to calculate the cost of the matrix. That also we'll see. For getting the value of any intermediary vertex, the formula is A of k I comma j. K is what? The vertex number, intermediary vertex number. Minimum of A of k minus 1 of I comma j comma A of k minus 1 I comma k plus A of k minus 1 k comma j. Now I'll make this is simple with an example. I wanted to find out 4 comma 2 cost here in this 4 comma 2. K value is what I have taken from 1 4 comma 2. The value I wanted to take 4 comma 2. So minimum of A of k minus 1 means what? So the value 1 is I wrote here. K minus 1 means 1 minus 1, which is 0. That means from this matrix. So A naught I comma j. I comma j is what? 4 comma 2. So what is the existing cost? 4 comma 2 existing cost is infinite. Now A naught I comma k. I is what? 4. K is what? K value is what? To the vertex which you wanted to, to the vertex which you are taking an intermediary. So what vertex I have taken K value as 1, 4, 1. Okay, plus A naught K. K is what? 1. J is what? 2. Now 4 comma 1, do you have any value? Yes, I have, which is 2 plus 1 comma 2, do you have any value? 3. Yes. Among these two, which is minimum? Minimum of infinite and 2 plus 3, which is minimum? 5 is the minimum. So we will take 5 for this value. So this is the way how we are going to find out shortest path distance from each vertex. Now let's see how we will be going to find out using this formula. So you have to please keep in mind this formula. Now here we go with the problem solving. Right, now I'm going to start the procedure. I'm going to start the procedure with A naught. I wanted to find out 2 comma 3. Why 2 comma 3? Because it is 1 2 3 4. It is 1 2 3 4. So you have the values of from A naught matrix. you have the values of first row, first column. So you need to find out this element. So in this element is I'm going to find out a0 2 comma 3. So what is the formula? Minimum of a0 2 comma 1 plus a0 2 comma 3 comma a1 2 comma 3 a0 2 comma 1 comma a0 2 comma 1 comma 3. Correct? Now, so from next time onwards I'll take this value. Okay, a0 2 comma 3 value is what? a0 2 comma 3 value is what? 2 comma 3 value is 2. Now, so or else you can also write here 2 comma 3. Now a0 2 comma 1 2 comma 1 value is what? 8 from the matrix 8 plus, and this 1 comma 3 value is what? 1 comma 3 value infinite. Now which is lesser value? 2 is lesser or 8 plus infinite is lesser? Something if you add to infinite it becomes infinite only. Now 2 is lesser value, so here we will be considering 2 as the value. So I am just updating in the matrix that 2 is the value. Now the same you have to do it for next a0 2 comma 4. So a0 2 comma 4 value is what? 2 comma 4, it is infinite. Whether it is lesser or greater with this a0 2 comma 1 plus a0 1 comma 4. Now a0 2 comma 1 is what? 2 comma 1 is 8 plus a0 1 comma 4 is what? 1 comma 4 7. 8 plus 7, which this is 15. Infinite is lesser or 15 is lesser? Which is the minimum? Minimum is what? 15 if you compare with infinite. So 15 is considered. So I am going to write 15 over here. 2 comma 2 value is 0, right? So it is the value of 2 comma 3. 2 comma 3 is 2 and this is 15. Okay. Now, and the same procedure you have to apply for 3 comma 2. This value, to get this value, a0 3 comma 2 value is what? a0 3 comma 2 is infinite. Write infinite. Now compare this value with the with intermediary vertex. a0 3 comma 1 plus a0 1 comma 2. a0 3 comma 1 is 5 from the cost adjacency matrix. a0 1 comma 2 is 3. So which is minimum? Infinite is minimum or 8 is minimum? 8 is minimum. So I am going to take the value which is 8. And 3 comma 3 cost of II is 0. So there are two more values what are left, right? Which is 3 comma 4 and 4 comma 2, 4 comma 3. So if you get these values with the same procedure, the values will be 8 0 1 and 8 infinite 0. So this is what A1 matrix. A1 is what? Making one vertex as intermediary vertex, right? So this is what your A1. The same way you have to do A2. So A2 how we will get? I'll take it out. Now it will be fresh. Now go ahead. A2 is what? The matrix, the base matrix for A2 is A1. Base matrix is A1. From A1, whichever values you got, the second vertex values row wise, column wise you have to copy. So what is the A1? Just now we got no, that values you have to make a note. 8 0 1 and 8 infinite 0. So from this we will take only second column and second row values for A2 matrix. Now cost II is 0. I am just making cost II value 0. So you have to find out what? This 1 2 3 4 1 2 3 4. So we have to find out 1 3 1 4, all these values we have to find out. Now again find the values of A1 1 comma 3, A1 1 comma 2 plus A1 2 comma 3. Now this time intermediary vertex is 2. So A1 1 comma 3 value is infinite. A1 previously means A1 1 comma 3 value is infinite. I'll change the ink. A1 1 comma 3 is infinite, and A1 1 comma 2 is what? It is 3, and A1 2 comma 3 is 2. Infinite and 3 plus 2, which is minimum? This is minimum, 5. So update this 5 in the place of 1 comma 3. Now the next is A1 1 comma 4. Find the answer. So A1 1 comma 4 is what? A1 1 comma 4. 1 2 3 4 1 2 3 4. 1 comma 4 is 7. Now with intermediary vertex you also should check, right? 2 comma 4. Now what is the value of A1 1 comma 2? 3, and A1 2 comma 4 value is 15, which is minimum. 15 plus 3 is 18, and 7, which is minimum. 7 is minimum. So when 7 is minimum, we'll consider only this 7. So right over here, which is the value we got, 7. The same way you have to do the procedure for 3 1 and for remaining also. If you do the same procedure for remaining, the matrix will looks like 5 8 0 1 2 8 7 0. This is what the matrix. Now look at this. Earlier of A2, that is A1, this value is infinite. Now look at this 7 you got. So the more time you do according to the each vertex, you will get the more shorter distance to travel from one vertex to other vertex through intermediary vertex. So this is your A2. Like this you have to do A3 and A4. So this is your A3 and A4. So A3 is what? You should consider A2 as base matrix, and in that A2, whichever matrix you are taking as intermediary, that values you have to copy. So this is what? Third matrix. Third row, third column you have to copy. So after you get the values of third matrix, again for fourth matrix, you have to copy fourth row, fourth column and values. So that leftover values what are not available over here, we have to calculate according to the procedure. So that procedure we already know, right? Now for this A3 also we'll check one. That is, we'll find out A2 1 comma 2. 1 comma 2 value, this value I am going to find. This value I am going to find. A2 1 comma 2 and A2 1 comma 3. Now this time intermediary vertex is 3. A2 1 comma 3. Now A2 1 comma 2 is what? According to the previous matrix of A2, the value is 3. And these values are 5 plus 8, which is minimum. 3 is minimum. Now let's update this 3 over here. 3. Okay. Now in the same way you have to find all the values. A3, the way how you found 1 2 we found, right? You have to find 1 4 and 2 1 and 2 4, 4 1 and 4 2. All these values you have to find like this. Use the same procedure and find the values. So finally you will get A4 matrix, right? A4 is this. So the final values also I'll write because you can check easily. You can compare your result 7 0 2 and this is 3 and 5 8 0 1 2 5 7 0. This is final A3 matrix if you do the same procedure. Now 4 value A4, that means fourth vertex is the intermediary vertex. So copy this fourth row, fourth column here and find out the left values. So how to find out the values? Already I told you. So you just do the same process. You will get these values 3 5 6 and 5 0 2 3 and 3 6 0 1. So finally this is A4 matrix. So final the matrix are this. This is your base matrix, and this is making 1 as intermediary vertex, making 2 as intermediary vertex, making 3 as intermediary vertex, making 4 as intermediary vertex. Now as far as dynamic programming is considered, it works on optimality principle, that is sequence of decisions. These are what? Sequence of decisions. So this is about all pair shortest path problem. Now we'll see the algorithm, how it works. Now this algorithm is what? So here algorithm all paths cost a comma n is cost 1 to n is the cost adjacency matrix of a graph with n vertices. A I comma j is what? Is the cost of a shortest path from the vertex I to j. Cost ii is equal to 0 as we were discussed. N is the number of vertices what are available here. Now, so we already know that to represent a matrix we need for loops, right? For I is equal to 1. Outer loop is for rows and inner loop is for column 1. So A of ij is equal to cost of ij. So we'll represent the graph with cost adjacency matrix. So once after you know cost adjacency matrix, which is A naught. So from A naught you have to get A1. From A1 you have to get A2. From A2 A3. From A3 A4. So this sequence of decisions you have to take from after you generate each you have to take a decision, right? So for that I have taken this for loops. Look at these for loops. These for loops to for what? We are generating the matrix. So for which matrix you are generating? If k is equal to 1, now intermediary vertex is 1. If k is equal to 2, then intermediary vertex is 2. Likewise, k is what? It is intermediary vertex. You can generate from A, you can generate A1. After getting A1, you can generate A2, then A3, then A4. When the value of number of vertices is matches with n, then we'll stop the process of algorithm. So this is what shortest path, all pair shortest path problem. And this is this part is there in your implementation. So this is the algorithm what you have to implement in Java. Program should be in Java. Yes, thank you all.